All right, looking at this last problem, you're given a description of a drone carrying two identical packages. It goes up to some height h, right? So you have a height h. Then it drops package A downward, right? So this is package A downwards at a velocity v0, and then it fires package B upwards at that same velocity, package B, right? Comparing the two velocities for landing, I know your intuition would say package A should probably hit the floor with more velocity, but that's not the case. The reason is that this is a parabolic motion that B goes to, right? It goes up, then it comes back down. So by that point, it gets back to height h. It's going to have its downward velocity be equal to v0, just like package A does. And so they're both from height h going to head towards the floor with an initial velocity of v0 and be accelerated by gravity equally. So they both hit the ground with the same velocity, right? And if you want to kind of describe this, is that, you know, at height h, both packages will have a downward velocity of v naught, right? And they both travel the same height, so they both would hit the ground with the same velocity due to acceleration of gravity. So that's the point that you want to make sure you make, that the velocity at height h for both is going to be v naught downwards. And then we're supposed to derive an expression for the landing velocity. So the landing velocity is here, right? So velocity equations we have include this one, v0 plus gt, it's in the x direction, or not gt, at in the x direction, and then v squared is equal to v squared initial plus 2a x minus x naught, right? So that's in the x direction, but we're going to look in the y direction here. So first of all, in the y direction, acceleration is g, right? It's negative g. So if we want to know what the final velocity of an object, say, for example, let's look at object A, since it's being thrown downwards right away, right? Object A's final velocity would be equal to its initial velocity squared minus 2 times the acceleration, which is gravity, times the displacement, basically its final position minus its initial position. Its final position is 0. Its initial position is at position h. So I can kind of work this out, right? So that it becomes v0 squared plus 2gh. Okay, so that's my final velocity, and I would just square root the whole thing to get VA. So VA square root of V naught squared plus 2gh. I could go through the process of doing it for B as well, but it's going to be the same because they have the same velocity. So VB, it's the same as that, right? You don't want to use the one that has time. If you get involved with time in this problem here, you will end up with a quadratic formula and it gets really ugly. So this one works perfectly, right? The second equation we have here works perfectly. We have a displacement, we have acceleration, we have an initial and a final velocity. We care about the final velocity, we have the initial velocity already given to us. So there's no need to involve time in that case. For C, we're supposed to sketch the graph. Each package's velocity is a function of time from the moment they leave the drone and then until they hit the ground. Use the space below to sketch a graph. Okay, so I'm going to draw my 0 velocity right down the middle here. Okay. For package A, it's being thrown downwards right away, so it has a negative velocity to start with, and then it's accelerated by gravity. That was the most crooked line I've ever drawn. So let's say it like this, right? So I want to keep my slopes consistent here because it's important. So this is package A, right? And then this is my initial velocity, v0. Package B, though, is thrown upwards with the same velocity, so it would start up here, right? However, it immediately begins to slow down due to gravity, and so it would actually have the same slope So going like this would be the same slope, I believe. So it crosses this point here. There we go. All right, so now they're parallel to each other. And object B might take longer to hit the ground, but it would also hit the ground eventually, right? And so that's what the graph should look like. D is probably the easiest question here. Both have the same slope. Which is negative g, right? Due to gravity being the acceleration. Due to the acceleration of gravity. Right? And that's it.